Okay, are we on? We're not on, but we will be soon. There we go. There we go. We're live. So we're going to start with what it means to find intercepts. If we think about what the word intercept means, suppose that I am throwing you a football. If somebody intercepts it, what that means is somebody's crossing the path of the football and catching it, right? I'd like you to think of intercepts as crossing. The x-intercept is going to be the point where our line crosses the x-axis. Our y-intercept is going to be the point where our line crosses the y-axis. Now, if we look at a graph, and suppose I have a line. If my line is crossing the x-axis, if I have a line and my line is crossing the x-axis, say here, what is the y value of this point? Well, the y value of this point is going to be 0. So in order to find the x-intercept, I need to figure out what x is when y equals 0. I'm going to erase that because we're going to need to put a different line on that graph. So our x-intercept, going back to, whoops, wrong direction, going back to here, our x-intercept is going to be the x value when y is 0. Our y-intercept, similarly, is going to be the y value when x is 0. When you're finding intercepts, basically what you want to do is you're going to plug in 0. For x and solve. And then plug in 0 for y and solve. That's your basic process here. Okay, let's do an example. I look at this first problem. 4x plus 2y equals 12. So I ask myself, I say, okay, well, what happens when x is 0? What happens when y equals 0? So we're going to plug it in and we're going to see. I have x equals 0, and this is almost like making a t-table, right? Actually, this is the same as making a t-table, and I'm going to use 0 as one of my points. So when x is 0, I have this equation, 4x plus 2y equals 12. I'm putting in 0 for x. 4 times 0 is 0. Plus 2y equals 12. Get that line in there. Divide both sides by 2, and I get y equals 6. This gives me the point 0, 6. And I can plot that point on my graph, 0, 6. I'm not going to go left or right, but I am going to go up 6 spaces. That is my y-intercept. To find the x-intercept, I'm going to plug in y equals 0 and see what happens. 4x plus 2y equals 12. I'm putting in 0 for y. This is 4x plus 0 equals 12. 4x equals 12. Divide both sides by 4. And I find that x equals 3. That gives me the point 3, 0. In other words, when y equals 0, x equals 3. I can plot that point. I'm going to go right 3 spaces, and I'm not going to go up or down at all. Now I look at this, and I have 2 points on my graph. I can certainly connect them and form a line, but what I want to do is pick one more point. And if that point looks like it's going to be on this line, then we're good. But let's say I pick a point and I get a point out here. Well, with these 3 points, am I going to be able to draw a straight line? Absolutely not. So that tells me that somewhere along the way, I have made a mistake. So pick one more point. I'm going to choose a value, a small value for x. I'm going to choose 1. And this is going to be just to verify that I didn't make any mistakes, that all my points do form a line. I'm going to say, what happens when x equals 1? This is not for an intercept. This is just to make sure I didn't make any mistakes. So I have 4 times 1 plus 2y equals 12. I'm plugging in 1 for x. It's going to be 4 plus 2y equals 12 minus 4. 2y equals 8, divide by 2. And I find that y equals 4. So what this tells me is that when x equals 1, y equals 4. Now let's see if that point lines up with the other 2. 1, 4. If I look at this, do they look like they're in a straight line? I think so. So then what I'm going to do is just take a straight edge. I'm using a folded up sheet of paper here. And in fact, they do all lie in a line. So I connect them. And this is the graph of this linear equation. 4x plus 2y equals 12 has this for its graph. Now, I'm going to have you do the u-try. Same idea. What happens when x is 0? What happens when y is 0? And pick one more point. Test it. See what you get. Go ahead and hit pause at this point. Give this one a shot. And pause. All right. Let's take a look at the example. For this one, I'm sure you paused it and did it. You should have got 4 for your y-intercept. You should have got 6 for your x-intercept, and then whatever your test point is, along the way, it should all line up. So for the u-try, you should have landed on this. Okay. Example. Another way you can do this, when we plug something in, when we plug in 0, the whole term kind of just falls out. So to find the intercepts, what I can do, if I plugged in 0 for x, this whole thing goes away. And what I'm really left with is negative 2y equals 12. So when x equals 0, and that piece falls out, I have negative 2y. Did I say 12? I'm sorry, I meant negative 2. And now this makes the solving part of it just a little bit shorter. Similarly, when y equals 0, this whole piece here falls out. So if I cover it up, what I'm left with is 3x equals negative 2. Divide both sides by 3, and I get x equals 2/3. Yeah, I guess so. That's kind of horrible, isn't it? 2/3 as an x-intercept. So here are the points I have. I have 0, 1, I have 2/3, 0. So what I need to do then, is that right? 0, 1 by 3, -2. Oh, here we go. Something didn't feel right. So I divided both sides by, I should have divided by both sides by 3, but I actually divided by -3. Go ahead and erase that. And then this 2 is positive, so this should be negative. That fixes the problem. This is an awful point to plot, though, isn't it? -2/3. Where the heck is that? Well, -2/3 for the x is going to be just a little bit short of -1. 0, 1 is going to be right here. So again, we're not able to plot this perfectly, but I can kind of see that it's going to be right about here, which means my line is going to go along this direction. So I still need a third point to make sure I didn't do anything crazy. Pick any number you want. I am going to choose, I certainly don't want to get another fraction, right? So here's what I'm going to do. I am going to choose to solve this equation for y. I minus 3x. And you're going to see why I'm doing this in a second. Okay. When I solve this equation for y, what I get is y equals 3/2 x plus 1. So now what I'm going to do is that when I choose an x value, I'm going to choose an x value intentionally so that this fraction clears out. If 2 is in the denominator, I need to have something that will cancel, right? I want you to think of fraction busting here. If I have 2 in the denominator and I want to get rid of that, x has to be divisible by 2. In fact, x could just be the number 2. That would work. So we're going to see what happens when x equals 2. I have y equals 3/2 times 2/1 plus 1. My 2's are going to cancel. I have y equals 3 plus 1, y equals 4. So this gives me the points 2, 4. Solving for y lets me choose x values that will make sure my points do not have fractions in it, like we have here, because I don't want to plot a bunch of points with fractions. That's ridiculous. So let's see if 2, 4 lines up. Does it look like all 3 are in the same line? Well, I think so, right? I took the lead out of my pencil here so that I could do this and show you. There you go. So they do all form a straight line. And I grab my straight edge and draw my line. So this is my graph. Again, if you get fractions in your points as you're picking points, if you're getting fractions, what you can do is solve this for y and then choose x values that will make those fractions go away, which is what we did here. Okay, let's talk about vertical lines and horizontal lines. We have vertical lines, we have horizontal lines. I want you to think which, a vertical line means the line is going to go up and down, right, like this. So let's say that I have my vertical line here. What x value is it cutting through? Right? If I look at this, this is passing through x equals 3. And no matter what my y value is, if I look at this point here, this is the point 3, 5. This is the point 3, 2. This is the point 3, negative 4. No matter what my y value is, my x value is always going to be 3. So if we were going to graph that, if we were going to graph this vertical line, the x value is always 3. The equation for this line is just x equals 3. Vertical lines think of it like this. Vertical lines pass through or cross the x-axis, and the equation for a vertical line is going to be x equals some number. This tells me that it's going to cut through the x-axis here. So let's do another one. Let's suppose I have this line. What is the equation for that line? Well, I look at that vertical line. I see that it cuts right through that x-axis. It cuts through the axis at negative 2, and that is the equation of our line, x equals negative 2. Vertical lines, or I'm sorry, horizontal lines, same idea. Horizontal lines are going to look like this. Well, what axis is that passing through? That passes through the y-axis. Okay, what do you think the equation of this line would be? It cuts through the y-axis at 4. This equation, or I'm sorry, this graph has the equation y equals 4. Let's do another one. Right there. That line is passing through which axis? Well, it passes through the y-axis. And where does it pass through the y-axis? Passes through the y-axis at negative 3. So that would be the equation of that line. What about this, though? What if I have that? This cuts through the y-axis where? It crosses through the y-axis at 0. The general form for a horizontal line is going to be y equals some number. Cuts through the y-axis at whatever that number is. All right, that is 3, 2, 3, 3. We got 3, 4 on the back. And yeah, actually, we're going to close this one down. This is 3, 2, 3, 3. Thanks so much. Have a wonderful day.